Now we are taking a turn, but not really. So he's also in 3D printing, into 3D printing. But Thorsten, our next speaker, is also a software developer. And the funny story behind, and I told it to many people today, where I come from UI and UX design, and I joined conferences like this with the same concept here in Amsterdam. So that's mainly also the reason why we are in Amsterdam, because I joined those DevWorld conferences like the Vue.js, JavaScript conferences and so on. That's where I also met Thorsten, and he also helped out with building the website, and he's actually building the new website for the Printed World Conference. Right now, he's streaming on his Twitch channel, like giving others the opportunity to contribute and learn from his experience also. And he's talking about Web 101 with a heart from a web dev for 3D printing pros. Give it up for Thorsten.
So printed, design and make your ideas real.
Hello everybody and welcome to my talk. It's really nice to see that all you guys are stayed until the last of this day. I know it's getting late, we all want to go grab some food after this talk, so I try really to get my time that is running here and talk with you a little bit about the web technologies. It's a little bit it's something else from what you heard from the other talks on this day, because this will get a little bit more technical, but bear with me, these are only concepts. I will not live code here with you. I will not spam you with all the technical informations, all the hard words, the buzzwords, so to say, but I want to give you an overview so that you can then after the talk, maybe this evening or at the weekend, get them up and running yourself on the browser and researching a little bit of what you might heard and learned, but want to keep knowing a little bit more in depth afterwards. So you can find me on social media, on several social media platforms, like I already was introduced. Thank you for the warm welcome here also. I'm also on Twitch, streaming there the development of the new printed website for the conference next year. You can go also there, learn something. I make it really easy so that others can follow what I'm doing. Myself, I'm Thorsten Seischab. I'm a computer scientist and web engineer with a master degrees, currently working as a full stack developer. More the IT consultant side of stuff, so it's like 50-50. I tell people what they need for their companies, but I also develop the things that I say they need. So that's all the one compact there in mind. So my passion with 3D printing started in 2018. I don't know if you still know the Dagomar Neva printer. I have no idea if this is still known, but I had some problems back then, calibrating and all this kind of thing, and I made the paper, is it on the bed or not? I need the glue stick and everything, debugging. So at that time I was more the 3D printer guy, and then I went to the 3D printing with the printer, still 2020 with the Prusa E3, still until today, a great printer, a good printer. If you want to sponsor me a newer one, go ahead. But this is for me only a hobby. So my normal day work life is not only in the web, but more the IT consultant stuff. Web is a big part of it. And the good thing about this is that they both intersect really good. Because your printers at home also talk with the internet. They also have protocols they use between your computer and the printer, or between your computer, the server, and the printer, like the Bamboo Cloud or something like that. And I can really easily adapt all my knowledge there and getting my printers up faster, or my one printer up faster. So what is the web then? Yeah, it's a powerful platform where we can bring together interaction, data management, innovation, and all these kind of things. And I made you a little mind map here. We don't want to go into too deep into this, but I would bet that everyone here is using everything on this chart. Either you know it or you use it under the hood without knowing that you use it. But yeah, the web is very complex, it's very wide. The trend is that we don't want software installed on a computer. You know this trend, you have apps in the web browser nowadays, and so this is really just an everyday experience for you. So just to get you up in what we want to do in this talk, I really want to talk now about some basic concepts. You can write the concepts down, watch the video afterwards, and then get in there deeper on your own. So where should we start? We saw the mind map. The mind map is large, it's blowy, it's IT. Not everyone loves IT or wants to have something with IT. So let's start with the foundation of what is the internet. So in fact, on the one side, you are there, that's the right side, you are the client. It doesn't matter if it's your printer, your Prusa printer, your Bamboo printer, or your laptop, your television at the moment also. And on the other side, you have a server. Servers can have files, then they can have databases. And each device has a firewall, these little icons here. The firewalls on this example are not very strong, that's why they're a little bit grayed out, so that we can pass data through it, because if the firewall would be too strong, we won't be able to communicate with other devices. So we have a little thing called local area networks. A local area network is more or less just the connections between your devices. So your local area network is what you have at home. Also, the server has a home where he is living, so he is also a local area network. And between you and the server, there's the internet. But of course, internet is not a real world. We have there a so-called wide area network. So a WAN and a LAN are only catchwords for how wide your cables can go in the end of the day. And between those two, you are not only the only one there, and the server is not alone in your local area network. So maybe here, the client on the bottom is your laptop. Then you have on the top right your Bamboo, and on the top left your Prusa slice. And you see, the Bamboo has a very strong firewall. We will get there in just a minute. Also, the server here, the upper server has a very strong firewall, so we can't communicate with them. On the server side, it doesn't matter for you because you have one endpoint, you want to talk to one endpoint, and it doesn't matter if in the background, in fact, there are maybe 5 servers or hundreds of servers. If you go to google.com, for you it's just a website, it could be one server, you doesn't care that it's hundreds of servers that are communicating between each other. And you can route between servers and clients over all kinds of networks. You can, for example, in the WAN, you have a long cable with some switches in the side, but also in your LAN, you can communicate between your PC and your printers, and also the servers are communicating over wires or wireless, of course. And now you see that your Bamboo on the right side is not able to connect to the internet because of the strong firewall we have installed there, so there is no connection that can go in the network. But how do we communicate between endpoints? Via IP addresses. So there is something called IP version 4. That is these cool 4 numbers with dots separating each other. And there is something called IP version 6. You don't see it that often. It should have been at some point the new standard, but it isn't until today, and it's also out there since over 10 years or something like that. But it's more convenient to have smaller numbers because IPv6, so the version 6, it has very long strings that contains numbers and characters of alphabetical characters, and they are not as easy to just say and also type if you want to connect directly. But typing directly is not very efficient. So if you want to go to the server here on the left side, you have to type 194.13. Oh, that's not good. So we have something called a domain name server. And domain name servers are there out, plenty of them. They have tables inside of them where they store 2 columns. In one column, they have domain names, like for example here, todde.tv, my own website. And on the second column, they have the IP address that you should use. And if you type todde.tv in your browser, you ask a DNS server what IP address is behind this domain name, and he gives you the domain name as a number, like the 194 something. And then your browser knows, okay, I can now route with the number, not with the domain name itself. So that's how the DNS works at this point. So there's a little myth I heard already around that Bamboo, we don't know, but it's just an example, can shut down your printer, for example, from remote, so that the server at some point say, you're not allowed to use your printer anymore. That's technical possible, but not as that the server tells your printer to do something, but the printer must establish the connection first. Because if we look at this, you have only one public IP address. So here, can you see my cursor? Perfect. This is your public IP address from your network. You have only one public IP address, and all the devices are using this same IP address. So routing from your client from the right side to the left side is easy because we type in todo.tv, it gets translated to the number 194 something, and the server can interpret it and give you back what you want. But if the server wants to reach, for example, only this one client here at the top, that is your Bamboo printer, he would not only need the knowledge of your IP address, your public IP address, he must also get via your firewall and then what computer is there behind this one IP. You have several devices, so that is not possible. The way that works is that a client, for example your printer, connects to the server and is asking, am I allowed to be able to print and live any longer? And then you have a connection established. And the server can respond over an open connection, but cannot establish a connection on his own. So this is the concept, really, really easily explained. And therefore, in IT, we use two kinds of transport protocols. There's the TCP protocol. That is something that very easily said can everything you want to have, you really get. You can get the knowledge of what you get, and it's exactly what you want to have. Via UDP is something like, yeah, you can miss out something in the middle. For example, a website, you always want to have the full website. That should be transmitted over TCP. But a video, we don't care if one frame in the middle is missing. Okay, then it's 29 FPS at one point, and then 30 FPS at the next point. We don't care, the video can always continue. So that is where we use UDP. Also, there are application protocols out there. I think you already heard something about HTTP as a protocol for your websites, or FTP for file transferring. MQTT is something you use with your 3D printers already, and WebSockets is something that you can establish and keep open. And the S is just a secure way where you have private and public keys. Everyone that has a public key can encrypt your data, but only the person that has the private key can decrypt the message again. So the server has the private key and it will keep it private, but it can give out the public key to everyone so they can ensure that only safe connections can be established to your server. Okay, now we have already heard something about servers and clients. But what does that mean in the web? So we have two other very base concepts to talk about, the backend and the front end. Let's start with the backend. I'm sure you heard about this. A backend is something that runs on your server. It is not shipped to the client. It has some logic that is hidden under the hood. You don't know what the server is doing, but he is doing something if you want him to do it. It has no UI, so no user interface. And UX is just how you interact with it. So it has neither one or the other of this. And the front end, on the other hand, is shipped from the server to the client. It is what you can see. It's the website front page, if you want to call it that way. So it has an user interface, an interaction model for it, and it can be interpreted by your browser. And they talk to each other. So on the backend side, you have very many languages you can use just to call one. Here are, for example, PHP. You can have a backend written in Python, in Java. Doesn't matter. There are many languages out there because the server has to interpret it. You don't care how it is written because you have not the knowledge and you do not need to interpret it. The frontend, on the other hand, must be interpreted by your browser. So we have more or less only three components a web page is built on. You have always the HTML, that is the elements on your website. You have the CSS, that is the styling for your elements. And you have JavaScript or TypeScript in the back, that is doing some actions on click, for example, that something should be evaluated and something should go on because HTML is just static. And an API is what we use to communicate. So it is living inside the JavaScript part. And if your printer wants to have his print job from the cloud, then it's using an API to get it via this little connection then there. Okay, so that means that a website always needs a front end in order to be shown by the client in the browser, but it does not need all the time a backend, because if you do not need logic to be executed, you can just have, for example, Wikipedia. It's just plain text. You can store it on a server, ship it to the client, display it there, and that's it. But you always need a server to ship it. So a server is not necessarily the same as a backend, and that is important to know that there is a difference. Okay, so let's talk a little bit about how we can store your data. Just to give you a catchword, there's something called Git in IT that you can use as a version control system for storing different versions of your code. It's like when you make your model, it would be nice to say, okay, this model has version 1 now, but tomorrow it's version 2. So the people that download your models know what versions are compatible with each other. Because if you're doing a more complex build, for example, that has screws in it or something like that, and you change them, they might not be able to connect to each other. And that is the same in software development. So we need something to store our versions, and that is where Git come in hand. We can track our changes, we can use it for our own or in our team. The data is then stored. And we use it exactly for this history and rollback thing approach, just to get our workflow even better than it is just on our local machine. Because when I lose my laptop, it's gone. And also, you cannot program with me on my laptop at the same time when maybe I'm at home and you're here in Amsterdam. That does not work. And therefore, we use exactly these clone approach, that a Git repository can be cloned. You can commit your changes to a Git repository and also pull them down again. These are just some words how Git works. Okay, now let's talk a little bit about data life cycles, because when you build now a portfolio website, for example, you need to know what kind of data do you have. So the structure is important on later deciding, do you need a server? Do you need a CMS? We come to that in just a moment. And in order to get the knowledge there, we must think about, do you have static data versus dynamic data? Some other words for this might also be, is it your data or is it someone else's data? For example, if someone writes a comment in your blog, then it's more the right side. But if you are writing your own biography on your website on the starting page, you're more on the left side. Or also, is it long-living data, like your biography should live long on your website, maybe change it once a week or something? Or have you short-living data, like the blog posts, maybe thousands of visitors per day will come to your website, so it's more a short-living approach there. And therefore, you can separate it in the development side. So on the left side, this data we know at development time. We know it when we build our portfolio. And the right side is the production time. So we do not know what will come later. So this is something that we should decide on storing in a database. So that is the right side, more the database approach. And the left side is more your static file system, built at build time. And the right thing is only fetched while your website is running in production later. Okay, I talked already about a little bit about CMS. What is CMS? It's a content management system. So something that you can use to get your data changed in a running website. So let's say you already built your website, you have your landing page. Of course, your name won't change, but maybe your profession will change. Or you want to upload a new model you created to your own website, and that is something you want to change really quick and not really in, let's run up the code for my website and let's code the new model in the website. That is impractical in the wide field. So therefore, we want to have a little content management approach, maybe with an editor, like in Notion or something like that. And there are different types to do so. So at least there are 3 known big types. At first, there's a traditional CMS. It's called the coupled CMS. You have everything in one place, like, for example, in WordPress. I think you heard already that name. It's out there a very long time. You can install it very fast, but you have some limits because you need a server for this. It is very slow. You can do so much things with it that it's nearly not always practical for your everyday needs. So there is where headless CMS come in. It's a rather newer approach that, but only means that you want to change your content because, for example, the design is something you only make once. So your design is ready and you only want to change the content, one new model, one new blog post. Only the content changes, and therefore headless CMS are way more practical than an old traditional CMS, because also in WordPress you can change your design, but you might don't want to. You change your design once a year or something like that. And also there is an approach, of course, where we use both of that. So a decoupled CMS, where you try to get both worlds into one approach. This is, for example, also possible with WordPress, but with plugins, for example, or with Experience Manager from Adobe. But you have to decide what kind of CMS suits you, because not all of them needs a server. We will come to that in also just a minute. Talking about exactly the servers now. We also have to have a place where your files are living. And of course, you can say, let's place a machine at my home. So I have a second room, there's the printer, and I can also, next to my printer, place my private server. Then you have some problems because you have to open your ports that other people can join into your private network onto the server. It's also a privacy problem in the end, because if you get hacked, they also might have access to your whole network in general and can also control other stuff you have there. But where should then our web page, our portfolio live? So one approach would be self-hosted. Your own hardware, your own machine, not specifically in your home. This is more like you can rent one. You can rent a self-hosted machine somewhere, for example, then like on a hoster. So we have the self-hosting at home in your second room. We have the private server where you rent your hardware at someone that rents hardware. Either you want a root server or a vRoot server, doesn't matter. These are just names you can use. But you have still control over the software. So you can still control your operating system via remote, even though you do not see the hardware itself. And the third and last option would be to use a cloud hosting. So that is where you does neither have control over the hardware, nor you have control over the software. You just say, this is my software application, this is my ready built portfolio, I want you to host it. I don't care what software you're running. I don't care anything about your structure. So this is the most easy way to get a portfolio up and running at the current date. And I have printed some examples down there if you want to go and check it out. So as a combination example, if you, for example, take a cloud hosting like Vercel or Netlify, the last two words on the slides, then you do not have to rent a server at all. You can just get your portfolio up there, and everything is managed for you there for you. So what do I need then for a new portfolio website we want to build? So we have already talked about the domain. Of course, that is important. No one wants to type in your IP version 4 address. Take a domain, a name that people can remember. After you have that, you need to think about your CMS, your content management system. So the recommendation about 93% of the time, a headless CMS is what you want to go for. You can still adapt it. It will not limit you. In the beginning, you can build it up and running real fast and can think about things you miss later better than now building your own infrastructure with multiple servers and stuff like that. That is overkill for the everyday usage. Now that we know what kind of data we have, now we know that we want to use, for example, a headless CMS, we can then think about a server, for example, a cloud hosting server. So with the combination of a headless CMS and a cloud hosting, you really only need to register once in only one website, and everything is managed for you, easy up and running. Also, you should consider using maybe Git for your resources. Your images might change, your own portfolio, image of yourself, your profile picture is today some, but next year you are on a photo shooting, have a new one. So use something to get your resources in a history-like approach. Also, if you want to add to your headless CMS some new code, you could think about two things. Either you can program it yourself if you have the capability of this and want to learn something. Then a really good advice, do not start with plain HTML or PHP anymore. These times are over. Take a meta framework instead. So there are really, really good and easy meta frameworks out there. Just to call some of them, Vue is one, like Nuxt is one, built up on Vue. There's Svelte, Angular, React, and so on and so on. Take one of them. They are way more superior than plain HTML. Also, instead of program it yourself, maybe your CMS can do it for you. So some CMS, like the headless CMS Storyblock, has like a library built in for dependencies that you can plug and play into your website, like it was back in the days with WordPress. So if you need email, please type in your email address, we can follow up later. That could be just a block that you can use as a dependency without programming it, just like a builder, for example. So the next thing you should, okay, I already talked about these kind of integrations. The next thing you should really consider about is SEO, search engine optimization. This does not only mean that you want to be higher ranked in Google. It also means that you can share your code, for example, or your website over some chat software. For example, if you are on Telegram, WhatsApp, or social media like X, formerly Twitter, Instagram, or stuff like that, you want, if you paste your URL in there, that there is a little image, a little preview image. That is also part of the search engine optimization, even though it is not really for the search engine itself, but it can help you getting that the people know you faster. Also consider something like a USP. Your website can be very boring if you only have plain text in it and don't have anything that people can remember. And talking about a little bit of a USP would be, maybe you want to add toolings to your website, that people go there more often, not only to learn yourself and read about you, but also that they use the tools. For example, how much does a G-code cost when you print it? Let's add a little G-code to time and money conversion upload example, or a stunning 3D animation or stuff like that, that people remember you. Talking about 3D animations, this here, my slides, the whole time were a website. So I also can, because my slides are a website, add web stuff like this little benchy here. It's a 3D model, I can rotate it, I can click it. You could imagine, and that is also something we are building for the new website for this conference, do some actions that intersect each other. Let's imagine that this benchy is printed by everyone once in a lifetime. So you have a G-code of this benchy at home. And let's start when, let's imagine that when you go to your website and you are at the top of the website, the benchy is not visible, but while you scroll down, the benchy gets printed in the bottom top corner of your screen, and when you reach the top of your website, the benchy is fully printed. And that is exactly what we're doing on Twitch currently, so you can follow me there and check it out. So a G-code and scroll hooked together is something that will be there for next year for this conference. Okay, also, this is 3D here. I can also enable stuff like, maybe the model we need, stuff like that. So then we have the benchy, we have a plane under it, we have some shadows here. There are also some lights there, some light boxes. That is the more technical side, but it looks cool. It looks like you want to interact with it, you want to play with it. And because my light here is not long enough, the shadow is also not long enough, so I can extend my light, and while extending my light, also the shadow gets extended. I can turn off my light again, and then I have a little bit more of a realistically 3D model on a website at this moment. This is done via the GPU, of course. The GPU on your computer will render the image, we all know that. On top of the GPU, we have something called the WebGL. The WebGL is a low-level API in your browser with a direct GPU integration that can more or less take this little benchy, split it into vertices, send it to the GPU, and it gets printed. But because WebGL is a very low-level API, it's hard for it to code in it, so we use Three.js in the web. It's a more high-level framework that wraps around WebGL and makes it easier for us to take advantage of 3D in the web. And on top of that, we have also some wrappers for the specific meta frameworks. So if you, for example, take Vue or Nux, like I already said, then you should use Trest.js because it wraps Three.js, Three.js wraps WebGL, WebGL is on the GPU. And then you have a very easy and clean. This little benchy here, it's like 3 lines of code or something. So very, very easy. Okay, now we have 3D in the web. What can we do with it? All kinds of things. For example, we can build, of course, also games. This is a little game a friend and my, big shout out to Andreas at this point, made together. It's a little island, it's online, it's an idle game, so we can click on build places here. Then we can, for example, select a building we want to build. Okay, a little well. That costs, of course, time there to build, so we just want to speed up the time here. At some point, it's getting night. Okay, it's night now. At some point, it will get day again. Very fast. Now it's day again. And then we have built the little well here in our island, and it will produce gold for us over time. It's just an example, and if you open the debug menu, you can go there and check it out. For example, let's make everything on here. So yeah, you see here the light. The sun is nothing else than a directional light. It's going around in a circular motion around the island and producing shadows and stuff like that. And you can do that still with your models. So it depends on when you want to sell your models, then you can bring it in an e-commerce like approach. Clients can rotate your models. Client can change the color of the model if they change the filament, for example. They can also see how much time this will be. They can upload itself, and stuff like that is also possible. And you can build also very nice portfolios with it. Just an example, that is the next one. This is not from me. It's from Bruno Simon. I don't know if you already have seen this portfolio. It's a website. You can go there and check it out. It's a very nice thing where you also have, with Three.js, build a little thing where you can drive around with a little car. It's a portfolio website, and somewhere here we already see the code word Three.js. I mentioned already, he's also using it. This is the one framework to get 3D models onto websites, and this is a portfolio website. Okay, with this we are, oh, and also, just a little thing, this is when you post his website onto social media, it will generate this image here with a little text, and that is search engine optimization. You have an OG image text, and OG image and some description text that is part of search engine optimization. That's it with my talk. The talk is online. You can, if you want, make a photo of it. The presentation slides, sources, and also pre-built ones are out. You can open it on your own web browser and just give in the browser the website URL. Also, you can check out the game if you want to. And I have a full talk from another conference in the middle, playing with 3D on the web. This one slide where I printed the 3D models onto the web is also printed out there as a whole talk. If you want to learn more, 20 slides, go out, check it. Thanks for your patience and the 20 seconds longer talk I have given here.
Thank you so much, Thorsten.
Watch our project Zoom.